Hello and welcome to the second tutorial for eNanoMapper services. In this video we will provide an overview of the additional services made available in JaqPot. These are optimal experimental design, interlaboratory comparison and read across. The tutorial assumes that viewers have already made themselves familiar with the eNanoMapper modeling services demonstrated in the first video tutorial. Therefore, once users have signed in, they may access these services either on the main screen or under Actions. Under Optimal Experimental Design, users may choose Iterative Experimental Design or Factorial Design. Iterative Experimental Design allows users to design additional experiments for an ongoing research project, whereas Factorial Design allows users to design initial experiments. By clicking on Iterative Experimental Design, users are taken to the next screen. Here, they are prompted to select a dataset compatible with Iterative Experimental Design. This means that the endpoint column must be missing some values. As already explained in the previous video tutorial, JaqPot provides example datasets for all its functionalities. In this particular example, we have an example dataset containing protein corona data with missing values on the net cell association property. This is entitled Protein Corona Dataset for Experimental Design. The next screen should look familiar to JaqPot users, as it is almost identical to the modeling services screen. Here users must parameterize their algorithm. Specifically, users may select the optimal number of trials for their next experiment, the optimal design criterion, which can be chosen between the optimal, A-optimal and I-optimal, set an R² threshold, and select the design formula. Finally, users must select the input variables and endpoint, as well as whether they would like to apply a scaling method or not. Once completed, they may click on Experimental Design. In the results screen, users may see the R², normalized variance, and confounding effect. Preferred values for R² are close to 1, whereas for normalized variance and confounding effect, the preferred values are close to 0. Most importantly, below is the original dataset, with some of the rows with a missing prediction feature highlighted as potential candidates for further experiments. Even though the fields are editable already, it is evident that experiments cannot be carried out on the fly. Therefore, if users click on Save Dataset, they can proceed to carry out their experiments and then revisit this dataset at a later time. As with all datasets in JaqPot, this can be found under My Resources dataset. Users may return to the main screen by clicking on JaqPot. The next feature available under Experimental Design is Factorial Design. On this screen, users are allowed to define an experiment from scratch by specifying the number of trials, the optimal design criterion as before, and the design formula. Next, users may specify their variables by selecting their name, the type, and their levels. Levels must be discrete, not ranges. Users may also select to add a variable or delete a variable by clicking on Add Row and Delete Row respectively, and must fill in, of course, the dataset name and description. By clicking on Experimental Design, they proceed to the next step. The results screen shows the original dataset with the next experiments highlighted in red, just like with the Iterative Experimental Design results screen. The only difference is that these instances have been selected after a projection, as there are no values currently in the prediction feature column. As before, this dataset can be accessed under My Resources dataset. Once the suggested experiments have been carried out and some of the endpoint values have been filled in, this dataset is a candidate for iterative experimental design. The next feature we will talk about is interlaboratory comparison. This is a method used to assess bias amongst labs. A coordinator is responsible for collecting data from different labs. These comprise a dataset consisting of single or multiple entries per lab and, optionally, the reported uncertainty. Again, under example datasets, it can be seen that JaqPot provides a dummy dataset for interlab testing. The next screen prompts users to fill in the title and description of the model to be produced. Finally, a report is generated consisting of single values, array values, and images. Single values include the title, description, and the calculated robust average, standard deviation, and the uncertainty of the assigned value. Array calculations consist of detailed action signals, detailed statistics for which 8 discrete statistical tests have been carried out, detailed warning signs, a table containing lab real names to ensure anonymity, ranking array, suggestions containing the warning and action signals, and 7 figures to help interpret the results. As with all JaqPot reports, all table and single entries are editable, and every report is downloadable as PDF. Finally, the last task to be discussed in this tutorial is read across. The format of read across is identical to that of nano-QSAR modeling, where users can train a model and then make a prediction. The first thing users must do when training a read across model is to select a dataset. The second screen is for algorithm parameterization. Here the available parameters are distance between Euclidean, Manhattan, and ensemble, the threshold, which can be set between 0 and 1, the model name and description, and of course the input and endpoint variables. Users are also allowed to select a method for calculating a confidence value. Currently, only the nearest neighbor confidence is available. Once completed, users may click on See Result. The model result screen is identical to the model result screen for any of the nano-QSAR modeling implementations described in the first video tutorial. For any clarifications, please refer to this video. It can be seen that users may validate, predict, or delete this model. However, from the main screen, by clicking on Predict under Read Across, we may locate the model created or any other read across model and proceed. Finally, users may select a dataset for prediction. Please make sure that the dataset selected is compatible to the training set. Once completed, users may view the predictions by clicking on See Result. The prediction dataset contains the prediction feature and the confidence level. The nearest to 1, the better. By scrolling all the way to the right, users may create a QPRF report for any of the instances clicking on QPRF report. QPRF reports have been made available for all modeling services. They're all editable and downloadable as PDF. Thank you for watching.